the variance of x plus y would be equals to the variance of x plus the variance of y. X and y are independent variables, right? This will work out fine. But what happens when you have variance of x minus y? Then you actually get the same thing. And by same thing, I mean this is also a plus. Yes, and I think this is one that is very not intuitive for a lot of students. So this is where I want to give you sort of like an understanding of why it's an add, if your teacher has not gone through this already. So bear in mind that variance is actually a measure of spread, and when you're adding more and more variables, you're adding more variability to your results. And that's the idea behind this very confusing mathematical statement over here. I cannot show you what is variance, like I alluded to last week, but I can show you roughly how spread is increased when you introduce more variables. So let's look at a classic example. Let's say if I roll, right, okay, of a fair six-sided die, okay, then what is the expectation of x? 3.5. Okay, so now I need to introduce to you what I mean by spreads. The expected value is here, it's in the middle. Then I need to move to the left this amount and move to the right this amount to cover the entire range of values. That is what I mean by spreads. Okay, it's like a plus minus 2.5. Okay, so I say spread is 2.5. Is that okay? Yeah? Maybe quite intuitive to understand what I mean by spreads. We replace variance with spreads. So I'm going to do like a, maybe let's call this x. X is a blue die, and then y is a red die. I'm going to take the value of x minus value of y. So this will be your table of outcome of x minus y. Then let's do what is the expected value of x minus y. So for those of you who know, how do we do something like this? This is equals to expectation of x minus expectation of y. Yes, so the expected value is what? 0. Can you sort of see like the average value of this is 0? Maybe from the table outcome you can sort of see we have a 0 diagonal over here. Yes, and then on both sides of the 0, this balances out with this balances out with this balances out with this, sort of like you can cancel things. It will come down to 0. Yes? Yeah? Okay, good. Then let's look at the spread. So my claim is that when you subtract, right, x minus y, you're introducing more variability, right? You should be adding 2.5 plus 2.5. This is my claim. My claim is that the spread is 5. Whereas maybe naively you are taught, oh, then the spread should be 2.5 minus 2.5, the spread should be 0. You can clearly see the spread is not 0. Okay, so now if I draw a number line and say this is the expected value, then what is the leftmost extreme value now? -5. What is the rightmost extreme value? 5. Can you see the spread is 5? Okay, so this is the very idea of like, if you introduce more variables, you are going to have more uncertainty. Okay, yeah, so if this helps, maybe you can just take it in and then maybe copy it down. I'm just going to pause here for a while in case you have questions.